let's take a look at graphing cotangent functions now. And so at 0, we're actually undefined. So again, thinking about that's cotangent is x over y. So this is 1 over 0. So we know that it's 1 over 0, which is undefined. Then at pi over 2, that's going to be 0. At pi over 4, that's a positive 1 here. At 3 pi over 4, that's over here, that's going to be negative 1. And then at pi, we're undefined again. Okay, and at 5 pi over 4, we're at positive 1. At 3 pi over 2, we are at 0. At 7 pi over 4, we're at negative 1. And at 2 pi, we are back at undefined. Okay, so the period, again, if you go from 0 to pi, that is 1 period, so a period is pi. Our domain is all x, except x cannot equal n times pi. So notice that at pi and at 2 pi and so forth, we are undefined. The range is from negative infinity to infinity. Our vertical asymptotes is that x equals n times pi. Our x-intercepts now are at pi over 2 plus n times pi 0. And the y-intercept, there is none, right? So no y-intercept. This is symmetric across the origin, and so it's still an odd function. So let's graph one. So we know that the period for cotangent is pi, and we know that it's undefined at those points. So here's pi. Half of pi is pi over 2. Half of pi over 2 is pi over 4, and this is 3 pi over 4. Then we know at pi over 2, it's at 0. At pi over 4, we are at positive 1. Then at 3 pi over 4, we're at negative 1. So there is one period of a cotangent. Then we know we have a point here, and then it repeats on the way back. Okay, so it's very similar to a tangent, except it's shifted over pi over 2. So let's try an example. Let's sketch the graph of 2 cotangent of x over 3. So we're looking at a period change, and then it's also that first point changes. It's not an amplitude because it's not like the highest point there. So now in this case, when we're trying to find the vertical asymptotes, it's a little different. So vertical asymptotes for cotangent functions, if you can't tell, is that you have to set the b over bx minus c equal to 0 on the left, and then the bx minus c equal to pi on the right. So remember, for cotangent, it was negative pi over 2, and then for bx minus c, for the right side, it was positive pi over 2. So this is how you would do it on this function. So we would do x over 3 equals 0, so we know that it's 0. Then x over 3 equals pi, so x equals 3 pi. Oops, 4 out. 3 pi. Okay, so another way to think about it as well, so just like for tangent, I told you that if you know that what the period is, you can divide it in half and find the asymptotes. For cotangent, it's different. Once you know what the period is, that's where the asymptote is, if it's not shifted left or right. Okay, so this is at 3 pi. Half of 3 pi is 3 pi over 2. Then half of 3 pi over 2 is 3 pi over 4. And then this last one is 9 pi over 4. So we're at 0 here. The highest, that point on the left, an important point, key point, is 2 on the left, and then negative 2 on the right. Okay, and then of course you should fill out your graph, labeling each of the important points. Filling out the graph completely. So try this example on your own. Y equals cotangent of x over 4. Okay, if you try this out, you would have seen that the period is 4 pi, and here, I have 4 pi here, divide in half, it's 2 pi, half of 2 pi is pi, and then this is 3 pi, so this one is really nice. And then, of course, filling out the graph completely, labeling your x-axis and the y-axis for those important points as well.